This video is entitled Creating a Main Definition and is part of an Introduction to STEM Programming with Python 3, Chapter 8. I'm James Reneau Ph.D. From Shawnee State University, and I'll be taking you through this video presentation. In this video, I want to go through creating a main definition, calling the main definition, and just a little bit about why we would want to do this in our Python program. The main function. A lot of programming languages like C, C++, and Java, all programs have a definition called main. Usually it has no arguments, but sometimes it does. This is the place where your C program will start to execute. It automatically, you don't have to call it, it just starts there in the main function. It's not necessarily Pythonic. It's not necessarily a Python requirement that you use a main function, but you may see some programmers say to use it. It's a way to separate the startup code of your Python program from the rest of the program. But unlike in C and C++ where main is called automatically, you have to be sure to call the def main. And again, why would we do this? Well, we'll talk about that in a future slide. So here in this example, you can see that we have two definitions. I have a definition called foo, which just prints foo. And then I have a definition called main that contains a loop for 10 times around calling foo. And then on line 8, you can see that we call main to start the program. So the program actually starts at the top, defining foo, defining main, going down to line 8, which starts the program, which causes us to jump back up to def main, which causes us to go through the loop on 5 and 6 10 times, calling the def foo. So you can see how we're calling main and then calling foo and then calling back out. So there's an example of def main just used so that we can see an example. Let's now talk about why we would do this. The reason that we want to consider this and the reason I've brought this up is because of variable scoping. Variables created outside a def. So if I create a variable outside the definition or outside any definition, they are visible inside the definition. You just use them and they're there. They're sometimes called global variables. The problem with global variables is, well, it kind of breaks the whole idea of encapsulation. It breaks the whole idea of the definition being this reusable thing that you don't have to know how it works, and that it doesn't care what your variable names are outside. Because if you're using global variables, it does matter what the name of your variables are inside the definition. The other problem with global variables is mutable variables like lists, dictionaries, sets, objects, and some others. If you change them inside the def, they're also changed outside without having to pass them by name, which again can become problematic. What the def main will do is if you define all of your variables in the def main, then there are no global variables because there are no variables defined outside of a definition. So that keeps that from accidentally happening or keeps you from being careless and doing that. Global variables are sometimes required. There are some examples where you absolutely have to do it that way, but again, they're strongly discouraged. Again, variables created inside of one def are local to the def and not visible to other defs. And I can't stress enough that using global variables, unless you really know what you're doing, unless it's absolutely, completely necessary, is kind of something that you should avoid as much as possible. Let's look at this program. This is confusing as can be. It uses global variables. This is an example of what not to do. For instance, on line 9 and 10, I have the variable I and the variable L. I is a global variable and L is a global variable, so I and L exist both to main and to the function foo. Look at what the function foo does on line 2. Um, it appends I, so it appends the global variable I to the global variable L. And then in def main, I say for I in range of 10. Now, the variable I inside of main is not the global variable I, it's the local variable I belonging to main. So it loops 10 times, calling foo, which if you look on line 7, we print the list L after we loop through I 10 times. But notice that it appended 99 10 times, not 0 through 9 as you would expect, because again, the variable I on line 5 is local to the definition main, where the variable I on line 2 is a global variable. Global variables and variable scoping can become extremely problematic using global variables, and I just would strongly stress that don't do it if you can avoid it. Yeah, just don't do it if you can avoid it. This presentation was copyright or is copyright 2020 by James M. Reneau Ph.D. You can contact me at jreneau@shawnee.edu with any questions you may have. This work is licensed under a Creative Commons Attribution, Non-Commercial Share Alike 4.0 International License, and I would like to say thank you for watching.